Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 43, Bonding Part 3. Here are our objectives for today's video. Pause here. So in our last video, when we were specifically talking about polyatomic ions, I told you that it doesn't really matter, say, which oxygen you pick when you put on a negative charge. And sometimes there are more than one correct way to draw a Lewis structure. But in physical reality, those multiple ways to have Lewis structure actually means that the real structure is the hybrid of the two structures. So what I have listed here is benzene C6H6. The true structure of benzene actually has those double bonds evenly shared amongst all 6 of the carbon atoms. And that's why it's incredibly stable. It's something called aromaticity that you'll hear about if you ever take organic chemistry. You really don't need that for the purposes of this class. So you'd have all your standard single bonds, but rather than having either the one on the left or the one on the right, I'm representing it as a dotted line, but this is actually a shared sort of hybrid. So each one of these carbon-carbon bonds is actually more like 1.5 bonds. And what that means is that you have some incredibly stable structures as a result of resonance. Pause here. So we're going to just draw the individual structures, not the hybrid structure like I've done here. And it says to draw at least 3. So for the first one, there's only 3 possible. And the second one, you just only have to draw 3. When we write out the resonance structures, we typically use these brackets. So CO3, 2-, this is coming from your polyatomic ion sheet. And then all I'm really doing is moving around the negative charge. And then I don't have space to include it in the line above it, but normally I would do it all in the same line. And some of you are probably looking at it going, but they're the same thing, just rotated different ways, and you're not wrong. And wow, that's a very crowded screen, but hopefully you saw it as I went. You're not wrong that they are the same, but what actually happens is that rather than having 2 localized negative charges and 1 localized double bond, we have 3 1 1/3 bonds and 3 negative 2/3 charge, so that it's much more stable that way. And then for the next one, it says you only have to draw 3, so I'm only going to do 3, but there are more. There's not a particular order that you need to do these in either. And the more resonance structures you have, generally speaking, the more stable something is. Pause here. So we have been using formal charge without calling it that for the last couple of days in class. So mathematically, it's the difference between the number of valence electrons that something would have in a free atom. So for example, oxygen normally has 6, and the number of valence electrons it has in the molecule. So for example, this oxygen here 6 minus 2 minus 2 minus 2 is 0. This has a formal charge of 0, so I don't need to label it. Whereas this one over here, 6 minus 6 minus 1, it has a formal charge of minus 1. Formal charge is just the charge. You don't have to do it mathematically. You can do it completely intuitively like we have been. But the reason why I give you this formula is because sometimes formal charges, let's say from your textbook or from another source, are not always labeled. So you might need to be able to check them for yourself. But while you're drawing out the structures, do it in the way that you've been doing where you're adding an electron, so you're giving it a negative charge. That's how I personally prefer to do it. I think it's a lot more intuitive and a lot more natural to do. Pause here. So all of the resonance structures that we've been looking at have really been moving around a negative charge around the same 2 or 3 or 4 oxygen atoms, which is very, very important. Sometimes there are other types of resonance structures where you're moving around negative or positive charge on different types of atoms. And then we need to consider formal charge when we decide which structure is the most stable. So the first point, if you can, having the least number of formal charges possible is going to be preferable. You're not always going to be able to make that happen, and that's fine. But then the second point, this is something that will pop up a lot. Negative charge should be on the more electronegative element, if at all possible. So for example, if you have a choice between putting a negative charge on oxygen compared to, say, sulfur, you're going to put it on oxygen because oxygen is more electronegative. Right, that is all for today's video. Thank you so much for watching and have a great night.